Hello students, in today's lecture I will discuss about numerical on transformations. In the previous lecture we have already seen about homogeneous matrix representation, and we have seen that all the matrices which are represented using homogeneous matrix representation system, all these matrices are of order 3 by 3. So in this slide there is matrices of translation, rotation and scaling, and we will follow homogeneous coordinate system for solving the numerical. So here is the first numerical. We have to find the matrix that represents rotation of an object by 30 degree about the origin. So basically we have to demonstrate a matrix of rotation in which the angle given is 30 degree, and 30 degree is positive, so the rotation is in anti-clockwise direction, and rotation matrix about the origin is basically it is cos theta minus sin theta and cos theta. So here we have to substitute the value of rotation angle as 30 degree. So cos 30, then minus sin 30, then sin 30 and cos 30. Cos 30 is root 3 by 2. Sin 30 is basically it is 1 by 2. So we get the final matrix at root 3 upon 2 minus 1 by 2, 1 by 2 and root 3 by 2. So this is the solution of first part of this numerical. Now the second question here is that what are the new coordinates of the point P 2 comma minus 4 after the rotation. So we are having one point P and the coordinates of the point is 2 comma minus 4, and we have to rotate this point in anti-clockwise direction with an angle 30 degree. So we are already having the matrix of rotation in which the angle is 30 degree. So what we have to do, we have to multiply the rotation matrix with the object matrix, and the object matrix is what? It is a point. So you can see here we are multiplying these two matrices. The first matrix is basically a rotation matrix and the second matrix is basically a object matrix, and we are multiplying these two matrices and we get the final answer as root 3 plus 2 and 1 minus 2 root 3. That means after rotating this object, this point P 2 comma minus 4 with an angle of 30 degree, the new coordinates becomes root 3 plus 2 and 1 minus 2 root 3. So we could have a rotation about origin or we could have a rotation about pivot point. So if there is a rotation about origin, then we can directly apply the matrix that is the cos theta minus sin theta 0, sin theta cos theta 0 and 0 0 1. We can directly apply that matrix. But if this is the case that we have to rotate the object about the pivot point h comma k, so it is an example of composite transformation and we have to perform three operations in that. First is translation, second is rotation about origin, and third is reverse translation. So what we have to do, we have to shift the pivot point about the origin, and as the point shifted towards origin, the object is also shifted towards origin. Then we are applying the concept of rotation and we are already having the matrix of rotation, which is we have already discussed rotation about origin matrix. And finally that after rotation we will shift the point, that is the pivot point, back to its original position. So this is a kind of composite transformation, and here we are performing three transformations. First is translation, second is rotation, and third is reverse translation. So here you can see that the pivot point is shifted towards the origin, so it is a kind of translation. So here we are applying the translation matrix as 1 0 tx. So the value of tx is h, 0 1 ty, the value of ty is k, and 0 0 1. Then after that what we are doing, we are performing the rotation about origin, that is cos theta minus sin theta 0, sin theta cos theta 0 and 0 0 1. And finally what we are doing, we are performing the reverse translation, and in that case we are having the value of tx as minus h and the value of ty as minus k. So we are multiplying these three matrices, and this is the final matrix that we got, which is cos theta minus sin theta minus h cos theta plus k sin theta plus h, then sin theta cos theta minus h sin theta minus k cos theta plus k, then 0 0 1. So this is the final matrix that we are getting, and we can directly apply this matrix in the case where there is a rotation is about pivot point. In that case we can directly apply the matrix. So here is a numerical for that. Perform a 45-degree rotation of a triangle 0 comma 0 b a 0 comma 0 b 1 comma 1 c 5 comma 2, and in this there are two parts. First we have to rotate the triangle with an angle 45-degree about the origin, and second about the pivot point, that is the p minus 1 comma minus 1. So in the first part, that is rotation about the origin, in that case we can directly apply the matrix, which is cos theta minus sin theta 0, sin theta cos theta 0 0 0 1, and here the rotation angle is 45-degree, and we know that sin 45 and cos 45 is basically what it is, 1 upon root 2. So we can directly substitute the value and we could able to get the answer. Now in this, the object is basically it is a triangle, so we are following the column representation, and we are representing any coordinate along the columns. So in this there are 3 points, so we are having 3 columns. The first column is basically it is 0 0 1, second is 1 1 1, third is 5 2 1. And for solving this numerical, what we are doing, we are multiplying the transformation matrix with the object matrix. So this is the rotation matrix that we are keeping first, and this is the object matrix, and we are multiplying these two matrices, and finally we could able to get the answer. Here one thing you should remember, matrix multiplication is not commutative, so the order of matrices is very important. So you cannot say that A into B is equals to B into A. So this order should be followed, and whenever you are solving any numerical, you should write the transformation matrix first, then you have to write the object matrix. So the multiplication would be transformation matrix into object matrix. So here are the new coordinates of the triangle, that is a dash 0 comma 0, then b dash 0 comma root 2, and c dash 3 by 2 root 2 comma 7 by 2 root 2. So in the second part, what we are doing, we have to perform the rotation of the triangle with 45-degree about the pivot point. So we have already discussed the matrix of pivot point, and it is a combination of 3 matrices, and we can directly apply the formula here, and we could able to get the answer. So yeah, I am directly applying the formula of rotation about pivot point. This is the matrix which we directly apply, and we could able to get the answer from this matrix. And you can see that this is the final calculation, in which we are keeping the rotation matrix about the pivot point first, and then we are multiplying the matrix with the object matrix, and here we could able to find the answer. So the a dash becomes minus 1 root 2 minus 1, b dash becomes minus 1 2 root 2 minus 1, and c dash becomes 3 by 2 root 2 minus 1 9 by 2 root 2 minus 1. In this way we can solve any numerical in which there could be a rotation about origin, or there could be a rotation about pivot point. As we have seen the rotation about pivot point, similarly we could have a scaling about origin as well as the scaling about the fixed point. So the matrix that we have discussed, that is Sx00, 0sy0 and 001, is basically it is the matrix where scaling is done about origin. So in case of scaling about fixed point, we can, so in case if the scaling is about fixed point, we have to perform 3 transformations. First is translation, second is scaling, and third is reverse translation. So again it is a combination of 3 matrices, and we have to multiply these 3 matrices to get the solution. So here is a numerical. In this it is saying that magnify the triangle with vertices a00, b11 and c5, 2 to twice its size while keeping c5, 2 fixed. So again in this case we have to multiply three matrices. First we have to perform the translation. We have to move the fixed point about the origin. For that we have to perform translation. Then in the second matrix we are performing the scaling about origin because the pivot point is now at origin. And finally what we are doing, we are shifting the pivot point to back its original location. In this case we are not saying it as a pivot point, we are saying it as a fixed point. So first operation is translating the fixed point at the origin, second is performing scaling about origin, and third one is that we are moving the fixed point back to its original position. So this is the final matrix that we are getting, and what we have to do, we have to multiply this matrix with the object matrix. So here we could able to get the answer. So the new coordinates are -5 comma -2, -3 comma 0, and 5 comma 2. So this is the solution of this numerical. Now we could have a reflection about y is equals to mx plus b. We have already seen in the previous lectures that we could have reflection about x-axis, y-axis, reflection about xy, reflection about any line which is perpendicular to xy plane. This we have already seen. So there could be a reflection about y is equals to mx plus b also. So it is an example of composite transformation, and in this case we have to multiply 5 matrices. So first what we are doing, we are moving the intercept on y-axis at the origin. Then we are rotating the line y is equals to mx plus p with an angle theta. Then we are performing the reflection about x-axis. Then we are moving the line back to its original position, and finally we are moving the intercept back to its original position. So we are solving these 5 matrices, and we are substituting some values. We know that tan theta is equals to m, so from this we could able to calculate that sin theta is equals to m upon under root of m square plus 1, and cos theta is equals to 1 upon under root of m square plus 1. So by substituting these values of cos theta and sin theta, we could able to get this matrix, and we can directly apply this matrix in the case where we are doing reflection about y is equals to mx plus b. So here is a numerical. We have to reflect the diamond shaped polygon whose vertices are a -1, 0, b 0, -2, c 1, 0, and d 0, 2. And here we are having three parts. First we have to reflect the diamond with the line y is equals to 2. Then we have to reflect the diamond with the vertical line x is equals to 2, and then we have to reflect the diagonal with the line y is equals to x plus 2. So here we can directly apply the matrices. For the line y is equals to 2, in this case what is happening, we have to calculate the value of m and b. So in this we can see that the rotation angle is basically it is 0, but the value of b is what? But the value of b is 2. So you can directly substitute the value, and in this case you could able to get the answer. Similarly we can perform the reflection about x is equals to 2, and we can directly apply the formula, but you can also solve it in a different way. What we are doing, we are moving the point at the origin. So initially we are performing the translation, then we are performing the reflection about y-axis, and again we are shifting the point back to its original position. So it is a combination of three matrices, and we are multiplying these three matrices. We could able to get this final matrix, and finally what we are doing, we are multiplying this matrix with the object matrix, and we could able to get the answer. In the third case, the line is y is equals to x plus 2. Here we can directly see that the value of m is 1 and the intercept is basically it is 2. So we are substituting the value directly, and we could able to get this matrix. And finally what we are doing, we are multiplying this matrix with the object matrix, and we could able to get the answer. Next is shear transformation. Previously we have already discussed about 4 transformation, that is the translation, second is rotation, third is scaling, and fourth is reflection, and the last transformation is basically it is a shear. A transformation that distorts the shape of an object such that the transformed shape appears as if the object were composed of internal layers that has been caused to slide over each other is called as a shear. So shear is basically, it is a transformation in which the transformation which distorts or changes the shape of an object is called as shear. And it is something like that, we could imagine that the object is consisting of various internal layers and all layers are sliding on each other. So we could have a shear in x direction as well as a shear in the y direction. Two common shearing transformations are those that shift coordinates x values and those that shift y values. So here is an example of x direction shear. An x direction shear relative to x-axis is produced with the transformation matrix, which is 1 shx 0, 0 1 0 and 0 0 1. Or we can write in the equation form it as x dash is equals to x plus shx into y and y dash is equals to y. So whenever you are performing x direction shear, there is a change in the value of x but the y value remains the same. So here you can see that we are having one square and we are performing the shear along the x-axis with the value of 2, and you can see that the square becomes parallelogram. So the shape of the square has been distorted and the square now becomes the parallelogram. So this is all about the transformations. Thank you.